Hello everybody, welcome back. Today we're going to begin 4.2. This is the last unit for unit 4. We're going to learn how to graph rational functions, but the first part today for day 1, we're going to learn how to identify points of discontinuity and horizontal asymptotes. Okay, so first of all, I just want to kind of check this out here. I'm going to graph each of these guys in Desmos. So I'm going to open up Desmos here and bring it over and look at some of the graphs of these functions and see what they look like. Okay, so first of all, I'm going to bring over here Desmos. So let's look at first of all, this first graph here. It's just a line, y f of x equals x minus 1. Okay, and it's just a straight up line. Okay, let's look at here of x plus x minus 1 over 2, and it just basically changes slopes. But now let's look at this guy here. This guy, we have this asymptote is what we call it. Okay, and it's because x cannot equal 2, right? So you see this, it's called a point of discontinuity, this area where the graph does not cross, because if we divide it by 2, it would be 0. And then what about this one right here? This is interesting, right? Because we have this, it cannot be x equals 2, but what about this x plus 1? We come over here where x equals 1, right here, and what ends up happening is, look at that, we have a hole in our graph. It's undefined also, but it's a hole instead of an asymptote. So we're going to look at all these different kind of various ways we can have points of discontinuity on our graphs today. Okay. So first of all, just remember, rational function is any rational function of the form of some function divided by another function, where this q of x right here cannot equal to 0, right? And so the domain of our entire function here is all values of x for which the function of q cannot equal to 0. So it's basically all my real numbers except for when this function q is equal to 0, and that's what my domain is. Okay. So some of this stuff will look a little bit familiar because we kind of jumped to the back of the unit first and then kind of came back to 4.1 and 2. So some of this will look a little familiar. So just look at these 3 different graphs here. Notice that this one right here, we don't have any restrictions for x squared plus 1. There's nothing for x squared plus 1 that will be equal to 0. So this graph kind of just looks like this, okay? And you'll notice that this graph kind of hugs this line, y equals 0 right here, and we'll talk about these horizontal asymptotes later. But this line can be drawn without lifting up our pencil, so that doesn't have any points of discontinuity. This is a continuous graph. Okay, there's no jumps or breaks. Over here, we do have a point of discontinuity at 2 and negative 2, because if we factor this graph right here, it's going to become 1 over x plus 2, x minus 2. And so that's how we end up with these little asymptotes right here, where x equals 2 and x equals negative 2. All right, so the graph is discontinuous at that point, because if we draw the graph here, we have to pick up our pencil and draw the second half and pick up our pencil here. So it's not continuous, it's discontinuous. Same thing right here, my x cannot be equal to negative 1. So we have an asymptote right here, a vertical asymptote. And our graph kind of looks like this guy here. And this is also not continuous, okay? So how do we find these vertical asymptotes? Well, we kind of already did this in 4.3, 4.4, where we factor and find out, what values make our denominator 0. Right? So x cannot be equal to positive 1 or negative 2. And that's how we find our vertical asymptotes. So our vertical asymptotes, I just write it as VA, are at x equals 1 and x equals negative 2. So these are lines, people, okay? So we draw them as lines. And so you'll see them drawn as these dashed lines over here, okay? So the zeros of the denominator are at 1, negative 2. And the graph has vertical asymptotes right here at 1, x equals 1 and x equals negative 2. Right? Looking at this graph here, notice that we don't have an asymptote, we have a hole. Okay? And so this happens when we factor out everything and we end up having, let me get out of my design mode here. We end up having these two guys cancel each other out. We end up with y equals x plus 1. That's how we end up with a line, y equals x plus 1. And so this is still a point of discontinuity, but when we cancel out the top and bottom, it ends up being a hole instead of an asymptote. Okay, so we have factors cancel out, it ends up being a hole. Now be aware that a lot of times when we have these holes, they don't show up on graphs. Okay, so you need to be aware of them. So if I put these in Desmos and you just graph it, it's not going to show up. Okay, so if I just look at this graph, oh, it's just a normal graph, y equals x plus 1. You have to actually know where to look for it. Okay, so right here at 2, there's a hole, undefined. Okay, and so I don't know how to make it stay there. So 2 is undefined. So you have to know where to look for those holes in order to find them there. Okay, so there's a hole right here at x equals 2. Okay, so it's not always displayed, hardly ever on a graphing calculator or anything. Okay, Here's another one right here. We actually have a hole and an asymptote. Okay, so you'll notice on this guy, we do end up canceling factors out right here. So we have y equals 1 over x minus 1 left. And so that's my graph right here, 1 over x minus 1. So notice my horizontal or my vertical asymptote shifted over 1 right here. And then I have my graph here. And I also have a hole at, x equals 2. I have a vertical asymptote at x equals 1. Okay, because my factors canceled out, there's my hole. So I come over here where x is 2, and I go up to the graph and I put the hole in. So that's how you graph those holes. I go over where x equals 2, go up to the graph, and where it intersects the graph, that's where my hole is. And of course, I have my vertical asymptote here at x equals 1. Okay, so I have both a hole and an asymptote there. This last one's a little tricky. Okay, so if I factor these guys here, y equals x minus 1, or excuse me, x minus 2, and I factor this, x minus 2, x minus 2. So because these cancel like that, that should be a hole. However, because what's left over, I have 1 over x minus 2, I also have an asymptote. So I put my asymptote there, and because there's an asymptote there, there's nowhere to put a hole, right? So if I go to x equals 2, there's no graph to put a hole there. So whenever you have both a hole and an asymptote, the vertical asymptote is kind of what wins over, right? So we just graph our asymptote. There's no place to put a hole, okay? So right here, here's how to identify our different asymptotes and holes, okay? So this says that basically for every function, we have a point of discontinuity wherever this function equals 0, this q of x, okay? It's going to be either a vertical asymptote or a hole, one of the two. It's a vertical asymptote if there is no common zeros in the denominator and numerator. So here we have no common zeros in the top and bottom. So we're going to have vertical asymptotes at x equals 2 and x equals negative 5. Okay, so we have vertical asymptotes here at x equals 2 and x equals 5. Okay, and down here, there's a hole if there is a common zero in the numerator and denominator. So right here, we're going to have a hole. Okay, so we have, this is then going to be x equals 1 over x plus 5. So in this case, we're going to have a hole at x equals 3. We have a hole at here, x equals 3. And we're going to have a vertical asymptote at x equals negative 5. Okay, down here is the exception, because right here we have this factored into x minus 3 over x minus 3 times x minus 3 times x minus 5, right? And so these 3's will cancel each other out, but I'm still going to have another x minus 3. So that's going to be in the vertical asymptote only, okay? So vertical asymptote at x equals 3. And then we're going to have another vertical asymptote at x equals 5. No hole, because we can't put a hole on a vertical asymptote, right? There's nothing to put a hole on. Okay, so those are different conditions of vertical asymptotes and holes. So remember to keep a table of that somewhere so you can tell the difference, okay? So right here, for each rational function, describe this is points of discontinuity if they are vertical asymptotes or holes. Okay, so we're going to look at this first one. For y equals x minus 2 over x minus 1 plus x minus x plus 3. We don't have any common factors in the numerator or denominator, so that's going to be just x minus 2. And by the way, we're already factored. Sometimes you're going to have to factor these on your own, okay? So x minus 1, I don't know why I rewrote that, but whatever. So we're going to have vertical asymptotes at x equals 1 and x equals negative 3. And that's it. Okay, those are all our points of discontinuity. Okay, let's look at this next one over here. This one right here, we have these two factors cancel. So we know we're going to have a hole, right, at x equals 2. Okay, we're going to have a vertical asymptote at x equals negative 3. And that's it. Okay, let's take a look at the next one over here. Okay, we have an x minus 3. We have an additional x minus 3, so that's only going to become a vertical asymptote only. Okay, so we have a vertical asymptote at x equals 3. And we have another one right here, and that's going to be a hole because that cancels out. So we have a hole at x equals negative 4. Okay, and that's everything there. Okay, And then I should always make sure I rewrite all these functions. By the way, this will be y equals 1 over x plus 3, and I would graph that guy. This will be y equals 1 over x minus 3. And we'll get into graphing these on Thursday and Friday, okay? Okay, now let's talk about horizontal asymptotes. So we found out how to identify our vertical asymptotes and our holes. So now we're going to look at horizontal asymptotes. There's only 3 conditions for horizontal asymptotes. They're fairly simple, okay? So whenever we have this guy here, since the degree of a numerator is less than the degree of the denominator, okay? So my degree of a numerator is less than the degree of the denominator. My horizontal asymptote is always x equals 0. That's it. Okay, so it's my x-axis, basically. Okay, my x-axis. All right. So anytime the power on the bottom is bigger than the top, x-axis. Okay. If the powers are equal, so it's the same, the powers are the biggest, we're going to divide our leading coefficients. Okay. So we take our 9 divided by 5, and so it's going to be x equals 9/5. Excuse me, y equals 9/5 right here. Okay, and then we take a look at what if my degree of the numerator is larger than the degree of the denominator. So it's bigger on top than on bottom. There's not going to be any horizontal asymptote. So we only have 3 conditions. It's either going to be the x-axis. I finished on my x-axis there. It's either going to be the x-axis. It's going to be no horizontal asymptote, or we're going to divide. It's one of those 3 things. That's it. You just have to remember which one. Okay. So again, if the numerator is smaller on top than the bottom, it's the x-axis, y equals 0. If it's bigger on top than on bottom, it's no horizontal asymptote. If they're equal, then we divide the leading coefficients. Okay, so here's a little table for that. So if m is my power of my numerator, and I remember that m for the numerator, n is the power of the denominator, so I remember that n for the denominator. So if m is greater than n, there's no horizontal asymptote. And here's my example. If m equals n, then I divide. In this case, it's going to be y equals 4/2, which would equal 2. Okay, so I take the 4 and divide it by 2, which would equal 2. If m is less than n, it's y equals 0, which is the x-axis. Okay, so let's identify here which of these are. Okay, so in here we'll notice that the power is bigger than the power on the top. Okay, so there is no horizontal asymptote. None. Okay, power here is smaller on top than the bottom, right? So this is going to be just y equals 0, my x-axis. This one, my powers are equal, so I'm going to take my leading coefficients, 4 and 1. That one's a 1, so it'll be y equals 4 over 1, which is y equals 4. So my horizontal asymptote will be at y equals 4. Okay, so that's how I find my horizontal asymptotes. Okay, so you'll be asked to find vertical asymptotes, horizontal asymptotes, and holes in this section. So you have an Excel in Google Classroom, and it's all going to be on just finding your points of discontinuity. Then we'll get into graphing those on Thursday and Friday. Okay, have a great day, and I'll talk to you later. Bye-bye.